In the previous segment, we studied sum rule and product rule of counting. In this segment, we will be studying permutations. We'll know the formula and solve some problems on permutation. So what does permutation mean? Permutation refers to different type of arrangements. What type of arrangements? For example, if we have four different digits, four different letters, we can arrange these letters as A, B, C, D, B, A, C, D, C, A, B, D, and so on. So these are different arrangements of the letters A, B, C, D, and these are also known as different permutations, right? So permutations refers to different arrangements, and here we can see that if we rearrange these elements, we get different permutations. So for permutation, order matters, right? In permutation, order always matters. It means if you change the order of the elements, then you will get different permutations. So now, at first, we will see permutation with repetition. How? Okay, let's say we have a lock here, and this lock has 4-digit password. 4-digit password. We have to unlock this lock. And here, as we can see, that for the first slot, since there are 4 different slots for the password being 4-digit, for the first slot, there are 10 options. How? The digits starting from 0 to 9. All the 10 digits are the options for slot 1. For the second slot, there are 10 digits. Third slot, there are 10 options. Fourth slot, there are 10 options, right? Okay, so here we can see that if we use the digit 0 here in the first slot, you can also use the digit 0 in the second slot as well. Third slot you can use 0. Fourth slot you can use 0 as well. That means all of the available options may appear multiple times here. So this is why if 0 0 0 0 is a permutation, here 0 appears 4 times, right? So this is why this permutation is known as permutation with repetition, right? Okay, so if the question becomes how many possible passwords are there for this lock, can you answer this? Okay, to solve this problem, at first we can divide this procedure into 4 different tasks, like task 1, task 2, task 3, task 4. Why 4 different tasks? As we know, inputting a digit in the first slot is task 1. First slot, task 1. Input a digit in the second slot, that is second task. For the third slot, it is third task, and fourth slot, this will be fourth task. So for the first task, how many options are available there? Yes, to input a digit in the first slot, there are 10 different options. For the second slot, there are 10 different options since we can use one digit repeatedly. In the third slot, there are 10 options, and in the fourth slot, there are 10 different options. And as we have to perform task 1 and task 2 and task 3 and task 4. Why have I written this like this? Because we have to perform all of those tasks. So the relation between the two tasks is AND, right? So from the product rule of counting, if we have to determine in how many ways we can complete this procedure, there will be 10 times 10 times 10 times 10, right? 10 to the power 4 different ways in which we can complete this procedure. It means there will be 10 to the power 4 passwords for this block. Here, let me ask you something. If there were 5 different slots, what will be the answer? 10 would be multiplied 5 times, right? So the answer would be 10 to the power 5. If there would be 6 slots, 10 would be multiplied 6 times. There would be 10 to the power 6 passwords. And if the options available for each slot would be 12, and the number of slots would be 4, then how many passwords would be there? 12 into 12 into 12 into 12, since I said that the number of slots would be 4. So the total number of passwords would be 12 to the power 4. So from this, can we generalize something that if there are n options available and r slots for them, and if repetition is allowed, how many different permutations would be there to perform a task? There would be n times n times n times, like n. And can you answer how many n's will be there? Yes, since there are r slots, r number of slots, so there would be r number of n's. So the total number of permutations would be n to the power r, right? Okay, if we understand this, then we can easily answer this question. For example, say there are 5 letters, and you know that your brother's phone password is a 3-letter password, and a single letter can be used multiple times. So for the first slot there would be 5 options, for the second slot there would be 5 options, for the third slot there would be 5 options. So the total number of options available for n would be, for options for this password would be n. So how many slots are there? N equals to 5 here, and the number of slots are equals to 3. So the total number of passwords that can be formed using these letters would be n to the power r equals to 5 to the power 3, right? Okay, as simple as that. So now we know what is permutation with repetition. Okay, what if there would be 4 numbers and there would be a password, 4-digit password for a lock, and I have told you that you can use one letter or one digit only once here. You cannot use this password, use this digit repeatedly, right? So there are 4 slots and you can use 4 different numbers. So for the first slot there would be 4 available options. For the second slot there would be, how many options would be there? Yes, 3, because one of the options or elements has been already used here in the first slot. For the third slot there will be 2 options, and for the last slot there will be only 1 option. So the total number of passwords using all of these only once would be 4 into 3 into 21, that is 4 factorial or 24, right? So this question can also be asked in this way: in how many different ways can you arrange all of these 4 elements? In how many different ways can you arrange all of these different elements? You can arrange these elements in 4 factorial or 24 ways. So if I would ask you that there are A1, A2, A3, A4 up to n, total n elements. If I would ask you in how many ways can you arrange all of these n elements, what would be the result? Very simple. Since we have to use all of these elements, so there must be n slots for these n elements. So for the first slot there would be n options, for the second slot there would be n options, for the third n minus 1 options, sorry, because you can use these elements only once. Okay, so I have to mention that what we are studying now is permutation without repetition. I repeat, permutation without repetition. In the previous page we studied permutation with repetition, so you can use a single element only once here. So for the second slot there would be an n minus 1 option, for the third slot there would be n minus 2 options, since two of them are already used here. For the fourth slot there n minus 3, and for the last slot there would be only one options remaining. So the total number of ways in which I can arrange all of these n elements here will be n times n minus 1 times n minus 2 times n minus 3 times up to n. And can you remember what is this product called? Yes, this product is known as n factorial. So we can answer a simple question from this example, that if we are given m elements and we have to arrange all of them, then we can arrange all of these m elements in m factorial way. So if we have 10 elements, we have to arrange these 10 elements. Then how many ways can we arrange them? Yes, repeat, 10 factorial. Okay, so now what if you are given 5 letters like A, B, C, D, E, and you are supposed to pick 3 of them and arrange according to your wish in these 3 slots. It means the total number of available options is now n for you, that is 5, and the number of slots are 3, and you can use one letter only once. So for the first slot there are 5 options, for the second slot there will be one less, and for the third slot there will be 2 less. So the total number of arrangements that you can make, or total number of permutations that can be made from these 5 letters using 3 of them, 5 into 4 into 3, that is 60, right? So here we could write this 5 into 4 into 3 as multiplied 2 into 1, and we could divide this with 2 into 1 as well. So you can ask, why did I do that? Okay, let's see, 5 into 4 into 3 into 2 into 1. What is this called? This is 5 factorial, right? And what is 1 into 2 called? This is 2 factorial. And if we try to compare these numbers with n and r, can we write them like this? Here in this case, n equals to 5, r equals to 3. So can we write it n factorial divided by n minus r factorial? Many of us may get confused. See here, we could write it like 5 factorial, like 5 minus 3 factorial. Here 5 is n, and 3 is r. So we can write it n factorial divided by n minus r factorial. Yes, we can see another example so that it gets clear. For example, you have 7 digits like 1, 2, 3, 4, 5, 6, 7. You have 7 digits and you are supposed to make a 4-digit number out of this 7, right? So you have to make 4-digit number, so there would be 4 slots, and you can pick a digit only once from these 7, right? So for the first, there are 7 options. For the second, there are 6 options. For the third one, 5 options, and here 4 options, right? So the total number of numbers, 4-digit numbers, that you can make out of this 7 is 7 into 6 into 5 into 4. So the answer, total number of, sorry, the result is 7 into 6 into 5 into 4. So can we write this like this: 7 into 6 into 5 into 4 into 3 into 2 into 1, and then we can divide this with this. See, this is equal to this because all of these factors will cancel each other, right? So in the numerator we can write it like 7 factorial, and in the denominator we can write it like 3 factorial, and it can also be written as 7 factorial divided by 7 minus 4 factorial. Now why did we do that? See, there were in options available, and there were R slots available here, and can we write here that n equals to 7 and r equals to 4? So it can also be written as n factorial divided by n minus r factorial. So if we want to generalize this, we get that if we have n options and r slots, and we have to arrange r elements out of this n, and without repetition we have to do this. So in how many ways can we arrange this, rearrange these 10 options in r slots? Okay, so the total number of permutations would be n factorial divided by n minus r factorial. Since mathematicians are lazy, so they express this term like n p r. It means out of n different elements, in how many ways can you pick and arrange them in r slots? Okay, so from this formula we can easily say that if there are 10 different elements and 5 different slots, then the total number of permutations would be 10p5, and from this formula we can say that this is equal to 10 factorial divided by 10 minus 5 factorial, that is 10 factorial divided by 5 factorial. Okay, as simple as that. So let's have another example. If I say that there are 20 students in one course, and a teacher will make a committee with a president, 3 members committee, okay? President, vice president, and a treasurer. So one president would be there, one VP, and one treasurer. So in how many ways can he form a committee out of this 20? And see, there are 3 different slots. For the first slot there are 20 options, for the second slot there are 19 options, and for the third slot there are 18 options. From the counting principle we can easily say that there could be 20 into 19 into 18 different ways through which he can form a committee, and it can also be answered using the concept of permutation, because the teacher have 20 different elements, which is n equals to 20, and there are different options, that is equal to 3, right? So the total number of permutation will be npr, that is 20p3. Okay, so now we know how to determine the total number of permutations where n options are available, and are different slots are there. So this is the end of segment 2. Thank you.